Hi, it's Tim from thermoforming.tech, and this video will be focusing project economy in thermoforming business. Lots of companies try to evaluate the choice of machine, choice of the mold, based on the business indicators such as profit which you get, the costs which you will have in process, and the added value which you generate. And today we will be showing different indicators and parameters and how any change in these parameters affect your project economy. And I know that if you're there in the industry for many years, you have all the answers. But if you just start and you have an idea, okay, how should I choose my machine? Because I have lots of parameters like forming area, cutting tonnage, installed energy capacity, power, all of these things, they don't give you the direct answer. It's like a car and you are driving and you have the gearbox and you have the clutch and you have like the gear shifting and you have the torque, you have horsepowers. And what you really need to know is what is the speed you're actually going right now. The same thing with the thermoforming production. All of these parameters are critical and they're important and they are affecting the amount of money which your project gets. But at the same moment, they are not giving you direct answer. And this is what we are going to try to solve in this video and find some answers for you today. Okay, let's get started. This is a price calculator which thermoforming.tech has developed for customers. And we're not going to discuss too much of this price calculator. Let's dive in and try to see how exactly parameters affect. So it is a random tray. We don't care about it right now. But let's say it is a polypropylene tray and it weighs like 15 grams. And we need to produce in 1 month like 3 million parts. And right now we're looking on a mold and a machine with 10 cavities and running 20 cycles per minute. And layout efficiency is 78%. And we have waste norm, like additional waste, roll change, startup, heating, and all the rest, like 2%. So overall efficiency will be like 76. And we will be discussing two options. If you run with a sheet purchase, and then you have to sell your waste with some price. And if you run your own extrusion, and we have set some parameters here. For example, we sell our tray with like 4 cents, or it will be easier to switch to the price like per 1,000 parts. So it's like $40 per 1,000. And let's go through the parameters. So we buy the material for our extruder with 1.5. And if we buy the sheet, it would be like 2 and selling with the 0.7. And now the system tells us what will be our material costs in this case. But we know that also we will have to spend some energy. So I don't know, let's say that our price of 1 kilowatt is 25 cents. And machine is running... machine with the chiller and compressor, I don't know, 55 kilowatts. Yes. The consumption of the machine. Then we have a grinder standalone, and it takes 25 kilowatts, and it will be making 200 kilograms of grinding per 1 hour. And if we have our extruder, we also need to set up like 150 kilowatts it consumes, and it gives us 550 kilograms per 1 hour. And then, like, to make this like a clean and complete picture, we will say that we have also additional costs. To sell the product, we need to pack it, we need to deliver, let's say it's 0.2. So now everything is set up, and we can see, exactly at this moment, we can see all the important parameters. So for example, we have this price of $40 per 1,000 parts. Then price per kilogram will be $2.66, $2.67. And as you can see, the added value per kilogram for the sheet purchase is 0. It means we're in red numbers. It's like negative business. And the added value per hour here is the same. But for our own extrusion, makes sense because we get like 80 cents, almost 80 cents per 1 kilogram. And every hour brings us $142 above our variable costs, which we have specified: material, energy consumption, and sales cost. And it will take us 250 hours to produce this amount of products. And as we can see now, the income is 120,000, and for sheet purchase, it doesn't make any sense, because our material cost is $120,911. So it means that we're actually not making any added value for our business, but we're making a little bit of loss with this volume. So it doesn't make any sense for sure, and the price has to be changed, modified. If we want to proceed here, an operating expense, we don't care about them right now, and this is the price to cover our costs. Like you see, it's like a little bit more than 4 cents we need to cover this price, and here is like 2.8 cents, and this is why we get some money above, and we have some added value. So let's try, first of all, let's try to find a price where both cases bring at least something, because for sure there are like not all the expenses and we will have to cover something else. So if we will be given a price of 45, then yeah, we get some added value per hour, and we get some project added value like 14,000 above. So yeah, now it makes sense to run in both ways. And for sure, if you have this price, then with your extrusion, you will be super profitable, and you will be developing your business much faster. Even though your costs are higher here for the energy consumption, your material savings here is amazing. And this is a first thing to think about. So if you don't have your own extruder and you buy the sheet and you sell the waste, then every percent of waste which you have affects your business directly and affects your project economy much more than anything else. So, for example, we will be playing here with the waste norm. Like, if the waste norm changes to 1% and we are focusing the added value per hour, now it's 56 for sheet purchase. So if I say it's 1%, wow, immediately we got plus $4 per 1 hour running, and we got a much better added value for our project. So let's see how it affects our own extrusion business. So our own extrusion added value is $202 per hour. And if I say my waste norm is 5, wow, it changed, but just a little bit. Yep, not that much. And if it is 1, and if it is 2, yeah, you see, it changes a little bit because we have to spend different amount of energy on our extruder, but it doesn't affect the pricing as bad as it is for a sheet purchase. So yeah, the layout efficiency is critical if you buy the sheet and if you sell the waste. And if you have your own extrusion, it affects, but still not that much. So as the next thing, which I would like to check here, how the number of cavities affect. And we will be checking what changes with the number of cavities. Let's say that we can run 12 up mode. As you can see, the added value per hour changed, but the added value per kilogram, did it? Yeah, a little bit, but not that much again. What does that mean? First of all, if we use less time and we produce more products, it means our machine works faster, and spending the same amount of energy gives us some saving here. And the same thing will be with the number of cavities. So if it is 10 up mold, 20 cavities, I need 250 hours, and it's 56 and 202. But if it is 15, wow, you see the change. We need much more time, and the added value per hour changes. So these are like the basics. And now let's go and try to discuss every of these parameters step by step. For example, let's take a look on the electricity consumption and how much of money we spend on it. So as I said, we will start with the energy consumption. What I do now, I remove any material prices. So now we have no calculation on that. We have like zero material cost. And also we remove like packaging, transportation. So the only cost which we have in process now is our energy consumption. And as you can see, for sheet purchase, we have to spend $3,437 for our thermoforming machine and a grinder if we have it. And for extrusion line, we have to spend $7,918 because we have our extruder and it is running and it is taking energy. So if I have two options on two machines, and one machine will be taking 55 kilowatts and another machine will be taking 80 kilowatts, what will be the difference for me? Let's focus now on shade purchase first. So instead of 50, I had like 25 kilowatts now, and I set 80 here. Wow, it's 5,000, you see. So this 25 kilowatts actually bring in a difference. If I say it's like 1 kilowatt, so yeah, you see, it means that every kilowatt which I have to every additional kilowatt increasing my cost by $62 based on the price of 25 cents per kilowatt. And what does that mean for me? If I receive from my supplier information that my machine consumes like 50, my machine consumes 70 or 60 kilowatts or 30 kilowatts. When you're running, for sure, energy was not that important before because material affects much more. But the world has changed. The price of energy is rising, and it starts to affect business, and it starts to be quite painful. So let's say that if we have price for 1 kilowatt 0.5 US dollars, then every kilowatt which actually your machine consumes costs you $125. And yeah, we're now talking about sheet purchase home. And now let's try to see the difference like between 55 kilowatt machine, 6,875, and 30 kilowatt machine. Wow, it's 4,375. And you can see, if you're an engineer and you say, wow, yeah, this is a difference, but that is not that much compared to material. That's true. But at the same moment, it's quite a big difference, and having like 2,000 difference in 1 month, or like not even in 1 month, in 250 hours actually. So it will be like 4,000 in 1 month, and then you multiply 4,000 by 12 months, and you get a huge difference. So this is how we can track down our thermoforming machine consumption and how it affects the project economy. And what about extrusion now? Let's see if something changes with the extrusion line based on this. So if we're running with our own extruder, we really save money on the material for sure, but we have more costs on the energy, which has to be there. So let's say our machine consumes 55. We don't care about this. Or let's do even more interesting thing. Let's remove the machine consumption, and we discuss only the situation where we grind the waste and on our grinder, and then we process the material and we extrude the sheet for our production. So now the system tells us that based on price 0.5 and based on these parameters, we will have like $8,962 on energy. If my extruder makes not 550 per hour, but 600 per hour, it's 8,289. So let's check like what's the price of every kilogram which we have. Oh, no, we don't do that. Let's check the price of every kilowatt actually. So every kilowatt on our extrusion line with the output of 600 to produce the sheet, which will be processed in 250 hours on our thermoforming machine, costs us $937. So if my extruder consumption is 150, I have to spend 8,000 to like 8,300, and if it is 200, it's 10,700. Yeah, you see the difference now. And when you're trying to find out which extrusion line is better for you, this is how you know that actually it's clear that every kilowatt which is there costs something, but now you can easily calculate and track that down. So let's get back to 150, and we have 8,289, let's say 8,300 just to simplify it. And now let's check what happens with the layout efficiency. So, for example, we will be running not with 78, but with 70%, and like 8% difference. Wow, you see, it was 8,300. Now it is 9,000 almost 600, so $1,300 with an 8% layout efficiency. And when you have an idea that you have your own extruder, and in this case the waste doesn't mean anything for you, you see how wrong you are, because actually the more sheet you need to produce for the same amount of products, the more hours your extruder will be working and the more sheet you have to get there from it. And this is how it also affects you. And again, before it was not that critical when the energy was like maybe 5% or 10%, but now with the energy price increase, it starts to affect you badly, and you should try to focus on the layout efficiency. Or if you already have the mold, maybe the waste norm is something you do have to focus on, like getting some ideas here, what should be there. So we're putting our machine back, so it's taking 55 kilowatts. It's a machine with a preheater. Yeah, polypropylene needs much of heating. So 6,800, like 6,900 for sheet purchase, and 15,164 for this setup, which we're having. This is something which helps us to understand the energy consumption. And still, we understand that if we are running with a sheet purchase, for us, much more important thing is our material pricing, because if we say that our energy costs nothing, we just remove it from calculation and we put back the waste and sales price. Wow, you see, yeah, we're talking about 6,000, 7,000, 8,000, and now we have like 108,000 on the material. So sometimes you have to focus on the material more, but you should not forget about energy costs, because as we discussed again, it is still there and it is something that really affects you. The next thing I would like to discuss here is other costs which are coming from sales point. It's like packaging, transportation, maybe some commission. So we eliminate our costs for the material and energy. We don't care about them now. So you can see we have no variable costs here. And we're saying that every kilogram which we sell has like 20 cents of other costs with the packaging, transportation, and everything. And you can see here, so it's like 9,000 in both cases. So if you run with the extruder or without, that is not affecting you that much. And if I have here like 15, for example, yeah, you see, it's very simple and very direct and very straightforward. And why it is important to consider, like transportation here means a lot. And you know that if you buy one track of granula or like one track of sheet, it will be around 18 to 25 tons. And if you are selling one track of thermoform parts, it will be like 4 to 7 tons. So you should consider it here. Or, for example, we know that actually we are having like sales commission, and for example, it will be 10%. So 10% for 4.5 cents. So we add them here, and we see how it affects like every on our like volume and on per kilogram. Yeah. So I hope this somehow explains to you which parameters you have to consider more. And the last part of this video, I'd like to make a couple of changes and to show you the comparison for like two configurations with a little like with a small difference of number of cavities, number of cycles, number of the layout efficiency, with the same parameters and price for material, for waste, and price per kilowatt, whatever. So now let's set up all the parameters. Material price, I don't know, 1.5. Sheet price, let's see, 2 is 0.7. 0.7. 1 kilowatt is 0.4. We still have this operating expense, and we will discuss it like the next part of the video. So now we have everything here on the table, and we can see that our like variable costs are almost double if we run with the extruder or if we run without. And look, we are running just 250 hours. It's not even a complete machine capacity. So I'm saving a PDF file for here. Let's call it like option 1. And we have all the parameters lined up here. And now let's do the option 2, which will be like 8 cavities running 18 cycles, running with 73% waste. And our machine will be taking 35 kilowatts. Yeah, if all the parameters are worse, then it's clear. So let's do something else. We have less energy consumption on this machine. And actually, we have like less cavities with the less waste, but we have higher cycle speed. So, for example, 22 cycles per minute. And now, if you're trying to compare these two options, it becomes really much harder because like all the parameters here are better than all the parameters there. Project economy is better there. So, but what if our parameters are actually like one of them is better, one of them is worse? So we have like a smaller forming area, but machine is running faster, and machine is running, let's say, with actually not more waste, but with yeah, I got an idea. So we say that it runs with 82, so it's a higher efficiency, but less number of cavities, a little bit higher speed, and less energy consumption because machine is smaller. So what I do now, I generate the PDF, and we call it option 2. And now I have 2 calculations. Let's check here for the costs. 115,000 versus 120,000. And here I have 60. So a smaller machine with less cavities on the mold, but a little bit higher efficiency for like the material usage and a little bit higher speed actually saves money for you, and you should not run for a bigger machine in this case. But that was not that obvious. You have to spend some time for calculating this. But if we're like running with our own extruder, so it's 64,000 here on the first calculation, and it is 62,000 here. So as you can see, even for extrusion line, if you run with extrusion line, it gives like a small advantage here. So let's try to make it even more complex. Machine is taking, let's say, 25 kilowatts, and machine is having 6 cavities, and it runs with the same layout. What will be here? Our yeah, as you can see, it actually didn't change that much. We still have 115,000, a little bit like saving on energy. And as far as we are not changing the layout efficiency, our costs are not changing that much. But number of hours actually increased, and we need to run more time to get this volume. But what if my efficiency will be like a little bit lower than the second option? So for example, it will be 79. And we save this one again, like option 3. And now we have 3 PDF files, and it starts to be a little complicated to jump between these 3. So what we do now, we go to comparison, and we have option 1. Let's add option 2. Option 2. Yes. And option 3. So once they are lined up, it starts to be much easier comparing them for every case. So let's go through this. We have the same tray. We have like 3 configurations. It's a polypropylene tray with the same weight. We produce the same amount of products. And we have 10 up mold, 8 up mold, and 6 up mold. And we are running like on a bigger machine, we run a little bit slower and with a less, with a smaller efficiency, 78%. The middle one has the highest efficiency, and the smallest machine has something in between of these. So economical parameters are the same, and actually the difference is about our kilowatt consumption per machine, because we're checking 3 machines. The grinder and the extrusion line, they're like doing the same thing. And now let's check for sheet purchase. Price per product we fixed as the same one, like 45 per one product. And price per kilogram is also the same. Well, it's clear because the price is the same here. And margin per kilogram actually varies. And we see that the biggest machine has the lowest margin per kilogram if we are running with the sheet purchase. And the smaller machine, it is a little bit worse than the middle one, but still much better than the big machine with 10 up. And it forces you to think that maybe you should not run for like the highest output, but maybe you should focus on the highest efficiency. And for this reason, for example, there is a company in Europe. I don't want to say the name, but maybe you get an idea. And they are one of the market leaders. So they are one of the most rich companies in the European market. And they run small machines. They run machines like 500 by 400, something like that. And they use dedicated machine with a mold, and they don't make lots of mold changes. They are focusing efficiency, first of all. This is like the priority number one for them. And I know lots of companies who have big machines and they have lots of molds on them and they're switching and playing with them. But as I can see now, if I don't have my extruder and I'm buying the material, that doesn't lead to anything good. But if I'm running with my own extruder, will it be the same here? So let's check margin per hour. Well, look, the biggest machine has the highest margin in 1 hour that it makes. And the smallest machine has the smallest amount of margin per hour. Let's go to financial results now. And let's take a look. If we buy the sheet, we have the same amount of income, but the target volume margin for the biggest machine is not that cool. It's only 14 thousandths. And look, the guys with the smaller machines who invested less and selling with the same price are getting more money and more added value in their business than a company with a bigger machine, which was more expensive, and with a bigger mold, but the mold is not that efficient. And for their own extrusion, the situation is a little bit different. As you can see, the target volume margin is much higher than for like sheet purchase, but still it is lower for the biggest machine. And that forces to think about something like, should you really focus on like bigger machine and higher output, or you should focus on something else and like be efficient for thermoforming? And what I can do here, I can like try to make a it's always thing that you have to calculate, because if we will add another 2 cavities, for sure it will be a little bit better. But I want to give you just an idea, like just to think about something and to focus on the indicators and to understand how they affect your project. And now in the last part of this video, I want to discuss with you like general way how you make the calculations. And overhead allocation is something which is really tricky and doesn't have a simple answer. But we need to understand that when you're choosing equipment for when you're choosing a new mold, or you're discussing which project should you launch, which is better, you should focus on something else than allocating of your overheads. They will be the same and they will not affect that much, and you have no idea about how many products will you sell. So you have to rely on something which will be like really rigid. And those costs which you will have in production and those income which you will get in 1 hour, this is something you can rely on. Then how many hours you will be running, this is something different. But let's say that we're having, for example, like 10,000 of operating expense. If we buy the sheet, and maybe 20,000 if we are running with our own extrusion line, for sure, like it will add more of these operating expense to you. So I'm not saying that go for that or go for this. It depends on many things on your market, but just start thinking that instead of adding and spreading them there, just keep them aside, calculate the added value for your project, and then you have the profit which you get. And your profit is actually is clear and calculated by deducting from the added value which you have created of those operating expense. And then you just calculate how many hours you need to run to cover them. So as you can see here, we run 250 hours and 177 hours will be taken for sheet purchase, covering the operating expenses for sheet purchase. And while our operating expense twice more than in sheet purchase for extrusion line, we'll cover them in 70 hours. But again, this is like not a promotion of your own extruder, because it is clear to anybody that it really changes your project economy. I just wanted to point out how to allocate your operating expense in a better way, in a more efficient way, because what we have to understand, if we will add them to the price, our price will increase. And if we increase the price, some customers will not buy it from us. And we will sell not 3 million, but 2 million, for example, 500 parts. And our operating expense, they will not be affected by that, like 500,000 output and sales decrease. We are not getting any savings on our salary. We are not getting savings on our utilities, on our office payments, so they will stay there. So this is why I just give an idea of not allocating them. So our video ends here, but for sure your thermoforming quest only starts. And I hope we gave you a little bit more clarity and you are able now to understand how the parameters correlate and how the indicators really affect your project economy. You can subscribe to our channel, or you can book a demo meeting or schedule just a consultancy meeting to discuss the project, because we had to develop these tools for ourselves. Like every day in 15 years, we're helping companies to make decisions about equipment, which way to go, which product to launch, and we were calculating this, spending lots of hours. And this is why we developed this tool, then we gave it to a couple of our customers, and then it became a product for the market. So I really hope you enjoyed it, and it gave you some value, and it gave you some clarity. You can make the things faster now, or at least you have an idea what to focus on and what to track down from the parameters from your suppliers, because the worst thing actually can be there, then you have like on the forming area and forming area number 2, and your supplier saying, look, I have 20% bigger forming area. It means that it's like 20% better for your business. Not exactly, not always. When you start to discuss efficiency, some equipment suppliers are saying this is mold related, not a machine related. And this is like 90% true, because not on every machine you can use every kind of the mold. Every machine has like its special parameters and its technology. So thank you for watching this video, and we really try to give as much clarity about the parameters and how they affect, and give you a couple of insights. So it's Tim from Thermoforming.tech. Stay tuned and contact me if you want to know more. Bye.